Hello, Stationeers. Welcome to episode 9 of Vulcan Getting Started. A new update has dropped, and we now have things like seeds and lots of different food things and ovens. Let's move this microwave oven over here. And it does mean that before you can can something, you have to cook it, and then you have to use this packaging machine to can it. I'm going to need some iron and some copper to make one. However, canned food now doesn't decay, which gives you a pretty good incentive to can stuff. Let's put this stuff away. We don't need it. After we get our food situation sorted out, we're going to be making an automated water production. So we need some liquid pipes. We're actually going to move the existing water production system over. Only need a couple of those. And we need some regular pipes. Don't actually need insulated pipes for this because we're going to keep it all outside and just let the heat go out into the atmosphere. Let's bolt down our new packaging machine. Open that up. You have to put cans in the top. Where to put the cans? Over on the shelf. Got some pipes. Going to need a pipe analyzer, liquid variety, to measure how much water we've produced. What was I doing? Oh yeah, wanted cans. So, can goes in the top, only put one in there. Then you need some cooked food. So let's take some tomatoes, put them in the microwave, cook one up. From what I tried, it doesn't seem like you can cook multiple at once. You have to do one at a time, kind of like the baked potato. Okay. We also needed a... There we go. So we're going to need to make 10 cooked tomatoes. Sorry, that was a pipe meter. The next thing on our list is we need a volume pump to inject oxygen into our water production setup. There we go. We technically have one, but we're actually going to need that for something else as well. You can start making some cables, because we're going to need cables to wire it all up. The one thing about this food thing is it definitely gives you more to do while you're inside during the day on Vulcan. But you can see that doing them one at a time in a microwave is going to get old pretty quick. There is an automated oven, but it requires Constantin, which we're not quite there yet. After we get our water set up, I think Constantin is actually going to be our next thing that we're going to go after anyways. Okay, let's stop that, and we're going to need IC housings. One IC housing. Need some steel. Keep this going. And we need some steel. Obviously, if we're going to automate the water production, we're going to need an IC housing. Automating the water production is actually problematic. The H2 combustor has an internal atmosphere, and yet it doesn't allow you to read that out with logic. I don't know if that's a bug or something, but it certainly complicates matters. Because if you want to do what we did, where we just overfill it with hydrogen and then put a small amount of oxygen in so that it doesn't combust, you can't tell how much hydrogen is in there. It's a bit of a problem. But I've played around with lots of different things. One thing you could do is just super cool the inputs and only feed super cold fuel in there. That's kind of the default way to do it, but it uses a lot of power. All right, let's make some of these canned tomato soup now. Got to put 10. They go in the top. We got to close it and then fire it up. Oh, some cool sounds on this one. There we go. Tomato soup. And if we throw this down here, it's not decaying. That's a good thing. Like actual canned products. Let's put these in here. This one, I think, yeah, it's decayed, but it's not decaying more. So the damage carries over. But that, but it doesn't decay any more than it already has. Now we're going to need an IC10, obviously. Gold, we have gold. You can go there. That's going to take a minute. Some other things we need are things like a flashing light and some stuff like that. Getting towards the end of the day, let's get ready to go outside. Eight degrees in here. Let's cool it off a bit. We're down to about a bottle and a third. We're going to want to top that up before we disassemble our water maker. Shouldn't take us too long to move it, but yeah, it's just a good idea to have enough water. Okay, IC10 is done. Let's make that flashing light. Keep making some pipes just in case. I'm not sure exactly how many we need. And they're cheap. All right, it's almost cool enough out there. It's good. I feel like I'm forgetting something. Yeah, I need a transformer to power this thing, and mostly just to separate the network. Okay. Go out here. Right. So I said I was going to fill up the water bottles first, so let's do that. Someone mentioned that this wasn't on. Okay, so I switched it on. It really doesn't matter. The thing, let's put that in there. Get some oxygen in here. The weather station seems to work fine if you don't switch it on, because the little windmill thing spins on it when there's a storm coming. So until you want to hook logic up to it, it really doesn't matter. All right, this is where we want to build our water production system. I've got to go get my parts again. Using the jetpack because I want to be fairly quick about this. Power's going to come here. We'll put our IC chip on this wall. We don't need that much power. I think this thing is going to max out below 300 watts, if my calculation is correct, which is kind of cool. If you want to go the air conditioner route and try to super cool it before it goes in, you're up around 600 watts once you add everything together. Okay, so that's where we want it to go in. I want to put the filler and and so on inside. That's the pipe analyzer. I think I want the power to go the other way. Yep, like that. Remember to turn it on. I was going to use these pipes here. But I need another pipe. I'm actually short. And a pressure regulator. So I actually need a liquid back pressure regulator too. Let's see if the water's finished filling. So that one's almost done. Sounds like it's done. Good. Turn you off. So I don't think there's any more water in there that I'm going to be wasting when I disassemble it. And no oxygen. Let's take these parts, start moving them. These we can actually place inside. Make sure we get them in the right spot. So I want the filler on the floor here. Good. And I would like this canister holder kind of matching the oxygen one. Right there. Good. Go get some more parts. We're going to have to start placing some of these parts soon. Clear up some inventory. Move that over there so we can see it from inside. And this one goes in there. And then we need the back pressure regulator. I want the power coming this way on it. And I want the flow going to the right. And make sure that's a back pressure. Yep. And we want it to 0. So basically, its job is to pump all the water out of the H2 combustor. Otherwise, a whole bunch of pressure stays in the H2 combustor because it has a fairly large volume. And it kind of is unfortunate we have to use 100 watts for that, but it's kind of the simplest way to do it. I forgot I needed one of these after I thought about it before. So this goes this way, and then the H2 combustor is going to pump into that. Let's take the rest of this apart. What am I going to do power over there? I think right now, let's just put the H2 combustor in there because it really has only one place it has to go. That's backwards. There. All right. And then we have to fill hydrogen into it, and I'm just going to fill straight from the atmosphere. That's what we were doing before, and it worked pretty well. It's a low power solution, and it doesn't really matter what temperature, so it can actually fill all day long. We've got a couple of these vents here again. Let's at least pull from 2 different grid spaces. Grab these vents. So that goes that way. I think I need to connect something else in there. Let's get the vents on. So we need to vent out everything that isn't hydrogen or volatiles there. Input from a couple different grid spaces here. And then this output, the way we're going to do it is we're actually just going to feed the waste back into the input so that we just kind of get a recirculation going. And that way it never overfills what's in the H2 combustor. It's kind of a neat little trick. Not really a trick. Basically, we're just creating a circular flow here. And I forgot that we need a tank, but we can just use a regular tank for this. We don't need an insulated tank for it. There we go. We'll let that build. Keep going. The reason I'm using a tank is to give it a bit of a buffer, but also so I don't have to use a pipe analyzer. Okay, let's get this. This is where the oxygen's going to get injected. We're actually going to inject from our pressurized side there, where we put the canisters in to fill. Just because eventually it's going to have a constant amount of pressure on the other side. I didn't bring my insulated pipes. So we only want to bring it out of there at a very small amount. One is because we definitely don't want to overfill it with oxygen, but also it only uses like 8 watts per percent, so we're only going to use 8 watts while that thing's running. And it's going to produce more than enough oxygen for us, because the pressure in that pipe is going to be reasonably high. Alright, so now I got to think about power here. All the power connections except for that volume pump are on the outside. Let's get this out of the way. I'm going to reroute this wire down. Just to get it out of the way there. And then that's going to feed power. I know I'm feeding from a transformer to a transformer, but that'll work. Well, we're going to come over this way, and then I have to mount the IC housing here somewhere. Let's just put it beside. And then we're going to have to come around to the bottom of this to pick up the data port on it. There, but we don't want to cross it to the other network on the bottom. We can cut this and get a wire back from it. Good. Now somehow we have to get our wires over around here. Maybe what we'll do is I'll start. I'm going to have a way to get the wire past this, so let's move this out by one, and we'll just put another pipe section in here. And then we can run the wire all the way along the back there. And then I'll start over here. And we'll just wire everything up around the outside. That goes there, goes there. We're going to need the power and the data on all of these since we're automating it. And maybe going around this vent is just going to cost more cable. Pipes are cheaper than cable. It is a survival game. All right. We'll just move this out by one. Maybe in the future I'll dangle it off the side. But for right now, this is fine. Let's turn a corner. Head towards the wall. And I also need to pick up this volume pump onto the same network here. And I'm going to put that flashing light there too. So let's go this way. Connect that over there. Just put this here while we're thinking about it. That's our warning light for the filters being low. those filters won't get used very fast, but I still do want to know if they get low. And connect that up. Okay, so we've got our network connected. Network and power. We are missing the tank. Let's go get the tank quick. It's going to start getting warm here really quick. Doors over here. Grab it. So let's stick this over here somewhere. I gotta get... Yeah, that direction. I don't know if I'm in the center. Let's do this. If I stick a pipe on here and then put it there, it should line up. There we go. We got it in the right spot. And we gotta hook up the data port on the tank. Like I said, we're using this as a power-free analyzer, which is nice. Let's grab this. We need to take this inside with us, and might as well pick up all of the cable while we're here. Ooh, it's starting to get warm. You can hear it when it starts to get warm. Good. Okay. So this volume pump, oh, let's see. So got nothing in there, of course. Volume pump, let's throw that in there with this. And we need a passive vent. What I'm doing here, I'm getting this stuff together to be able to get rid of our waste tank. I want to be able to dump my waste tank into the greenhouse and let it recycle the oxygen from it. We're running out of health. So let's go in here and do a little pit stop. Still got lots of water. These aren't decaying anymore. I don't really need the fridge. All right. Let's go see if we can set this up. Or should I program? I need a meter, and I need an extra 2 pipes while I'm in there. In fact, what I want to do is I want to expand the number of hydroponics pots. Let's get some iron in here. There we go. Yeah, that'll make 6. I don't think we need 6. I just noticed oxygen production is okay, but it's not super awesome. So if I add a few more plants in there, I just feel like it's gonna get back up to pressure faster. I just wasn't quite happy with the oxygen production level. Hopefully it can handle the extra plants as far as the cooling goes. I mean, if it doesn't handle it, we'll just take a couple plants back out. And I want a pipe meter for my little waste tank reclamation thing. Let's pick some of this up again. I know, I just threw it in there. Okay, good. Time to go. How's these plants doing? How's the filter doing? Okay, we still got lots of water. Oh, near 20 kPa. As we add more segments here, it's going to lower the pressure a bit. We just got to stay above 6. Let's put these down. 1, 2, 3, 4, 5. And let's connect with the pipe segments. Need a pipe wrench. What did that do to our pressure? 17, 18. Okay. Not too bad. Let's plant something in there. You know what? Maybe I should dump this pressure down, or this temperature down, so it helps keep that pipe a little bit cooler. Yeah, maybe that's good. We're just injecting colder air in there then. And let's plant one of those there. And we'll still have our line of tomatoes. All right, well, that should help a little bit. 0. Oh, there it is. It's on. Okay, so it's basically our oxygen accumulation tank is still 0, but we're still refilling that pressure with the pressure regulator into where we put the canisters, which is fine. That's where we're getting our air for the water. Let's get some power over to where we want to make our waste tank reclamation. Just stick something over in this corner. It doesn't have to be fancy. We need a volume pump. And let's set this all the way up at full. We're not going to run it much, but we want it to be fast. And we're going to have to come from this side and go that way. Okay, so up. And then I want to put an extra segment here so I can mount a meter, pipe meter. Let's see. Put that there, and it kind of looks like it's going to be in the way. Let's see how this looks. It's kind of in the way of the transformer, but I can get to the IC housing. I guess that's all right. That's not too bad. Wouldn't pass the safety inspection, but hey, we're on another planet. Okay, cool. It's got power. That works. Good. How are we doing in here? Still got 3%. That's good. Still daytime. All right. Let's start programming our water setup. Clear. So, first thing, we have a tank, D0. And we have a liquid analyzer, D1. Tells us how much water we have. And we have a liquid back pressure regulator. And we have a H2 filter. And we have our O2 pump. And we have our H2 combustor. 5, so 6 things. Kind of have a flashing light too, but I'm not going to worry about it yet. Here we'll do our regular start loop, end, yield, jump back to start loop. And let's see, the first thing we want to do is run our H2 filter to fill the tank. We need to know what our tank pressure is then. And we need to load our tank pressure from the tank pressure. Let's just do that. And it's nighttime. While we're out here, let's just start this thing filling. Let's see. We got power. Good. Get 0. All right, can't get through there. Let's go this way. And filter's ready to go. Let's filter. See what's going on here. Basically, we're just filling the tank with hydrogen volatiles. That's going to take a while to fill up. We want to make sure it's at a decent enough, well, pressure or volume, whatever, of hydrogen before we keep going. So let's get back to our program here. You know what? It's actually, it's not pressure. Pressure is going to oscillate a lot with the temperature going up and down during the day because it's not an insulated tank. We want the number of moles. So first we want to know how many moles are in the tank. So that's the total moles. And then we need our tank ratio of hydrogen. And we need to load that from the tank. So tank ratio H2 from the tank is ratio volatiles. Now, if we multiply those together, we can get the tank moles of H2, R4. So multiply into tank moles H2 from tank moles and tank ratio H2. Tank ratio H2. Good. Now, we want R0 to be on when tank moles of H2 is less than some large number. I think 2000 in my testing works pretty well. It won't be enough to overfill. You can use PV equals nRT to find how many moles would cause it to burst. We're way below that, even at highest temperature during the day. Or even, it's not even going to heat up that much from the H2 combustor. So I got to put some O2 in the tank. If at least say 1,000 H2. So we need to get the amount of H2 up to 1,000 to be able to start injecting oxygen, but we only want to go up to 3% because 5% approximately of oxygen will start to combust. And I want a safety margin. So load our tank ratio oxygen from the tank ratio oxygen. Good. So set greater than R0. So this is the first part. I need at least 1,000 moles of hydrogen. So our tank moles H2 greater than 1,000 goes into R1. Less than for R1 is we want to compare the tank ratio of oxygen to our set point, 3%. So for less than 3%, we can put more oxygen in there. So we need to add those together, R0 and R1 into R0. And then that is when we turn on our pump. So set pump on with R0. Cool. So we're filling with hydrogen, we're filling with oxygen. Now we need to make water. When do we want to make the water? Well, we got to look at our liquid pressure, R6. Our main thing is we don't want to burst a water canister that's in our canister holder. So we need to load liquid pressure from liquid analyzer pressure variable. And we want to be conservative on this. So because the temperature is going to fluctuate a lot. So a canister can, I think, still hold 10 MPa. So let's set less than into R0 if the liquid pressure is less than 4,000, so 4 MPa. That gives us lots of headroom for the temperature to oscillate all over the place. So then store into D H2 combustor, turn it on when R0 is on, and remember the liquid back pressure regulator also has to run always at the same time. So put in a little note, must run at the same time. Good. All right. That is everything we need to make some water. So let's export that, run that out. Bingo. Set the variables. That's the tank, small tank. So small. All right, it's a liquid pipe analyzer, and then that's the back pressure, but it's got a weird name. Back liquid pressure regulator. Yeah, weird. Filtration. This will be the O2 volume pump, and that is the H2 combustor. Let's turn that on. See what explodes. That's on. That, oh, and it turned off. What's in the tank? Okay, so it looks like we had 1,000 moles in the tank. It was enough to start putting some oxygen in there, and then at the same time the H2 combustor turned on and pulled a whole bunch of oxygen and hydrogen out of the tank to fill itself. So that kind of makes sense. Now the H2 filter is filling the tank back up. So that kind of looks like it's working. It's almost at 1,000 again. Can't go this way. You know, while it's nighttime, I think it's a good idea to do some mining. So I'm gonna set myself on a direction of 210, and we're gonna go get some stuff, mostly iron. Okay, we got a full mining belt full of ores. Sun is coming up, welcoming us to a new day on Vulcan. Got a nice little cinematic view of the base again. There's our water setup, humming away, and we've got 3.5 MPa of water in there. Something's actually working. Throw that away. Okay, we got 3% of oxygen in there. It has not combusted. Got 1.6 thousand moles. Let's get out of here. So that seems to be working. Very good. Oh, storm's coming. Glad I turned it on. I would have known either way. Get some of that going. Let's see here. Yeah, 4 MPa. So we've actually got full water in there. That's not reading. Oh, it's that stupid bug again. Let's take that off. Put it back on. I think it might have to do with whether or not you switch it. Let's just not rotate it too much and use the arrow keys or whatever. Delete page down keys. Got a little bit more. So it's used quite a bit of the oxygen that was in there to make that water, but now it's done making water. And throw that in there. Let's see what temperature. Oh, that's kind of funny. I pulled out the wrong thing. 134, 130. Yeah, those are actually pretty cool. So we could take those into the greenhouse and we can let them cool down further and then dump them into the greenhouse air. It's just carbon dioxide and oxygen. Oxygen will get filtered out. Back into our oxygen supply. So technically we still have 2 water bottles and we could make some more water. Ooh, 11 degrees. Let's take a drink. Good. Storm's coming. I lost my wrench. Where did I put my wrench? There's my wrench. Don't need a wrench. There's my wrench. That's good. I didn't want a melty wrench. And let's pop these in here. I got 4 MPa. That'll be hot water though, so it won't have many moles in there. Oh yeah, we used up all the water. But we just filled them, so that's good. Right, let's take these into the greenhouse. Now that we have a way to recycle our waste back into our oxygen supply, we can be a little bit more carefree with going out during the warmer parts of the day, because it's just not as big a deal. We're not worried as much about using up all our oxygen in a way that we can't get it back as easy. Let's harvest some of these tomatoes. Juicy tomatoes. You're still pumping. Temperature's doing good there. We're 28 degrees inside the greenhouse. It's kind of funny that this one has damage on it. I don't really understand what's going on there. It's like there's a glitch or something in the greenhouse. Strange. Okay. 11%. Still got a little bit of filter left. Good. Might as well can some stuff. Guess I want to make sure I only make 10 so I don't do something stupid and put 11 in the packaging machine. Okay. Close that. What else can we make? I need some more railings. Good. One thing I don't actually know is it actually worth it canning? Or if I can eat the cooked food directly, should I just be doing that? It's possible that the amount you get out of the cooked food is actually just so good that you just shouldn't bother canning it. But it doesn't hurt to have a long-term supply just in case. Great. I need some grates for out there too. Walking over all that stuff in the water manufacturing area is a bit of a problem. I just want to cover the floor with grates. I think 6 will do it. Yeah, this old microwave thing, it's going to get tedious fast. Keep doing that. I guess it doesn't matter. We actually have some temperature in there. We could throw some ores in, smelt that while we're inside. It's good. Oh yeah, 752. Gonna keep this going. Copper in there. Last one. Didn't put a can in yet. Let's put a can in. Go in the top. 10. Pull the lever first, turn it on. There it goes. And you got more copper. Looks like we're still good. I don't know if we're going to have enough heat left for the last one. Let's just see. Let's put the last bit of iron in there. And you're done. Good. Another few days worth of food. Starting to get dark out there. I was thinking we could update this program to turn on the flashing light. We need to define a constant flashing light and paste in the hash. And you've seen me do this before. Warn and filter load. Load slot. R0. DH2 filter. Slot 0. Quantity. And of course, load slot R1. H2 filter 1 quantity. Now we need to take the minimum of those two. Alias our min filter R7. And so we do min our min filter of R0 and R1. And then set, if we're less than, into R0, our min filter is less than 5%. So then store batch the flashing light on R0. Turn all the flashing lights on, which there's only one, of course. Okay, we're going to have to go out there and get the chip to reprogram it. How are we doing in here? Very good, 2,000 moles. And that thing's happy. Everything's working well. Not that I'm surprised. Okay, let's put this grading down. That's just going to make it easier to walk through this area. And let's turn the whole thing off so it doesn't do anything stupid. And reprogram this. I wonder when that storm's going to hit. Okay, export you, turn off. And there. Turn that back on. Okay, is it working? Yes. And yes, very good. Can put this railing up. Might actually be good if a storm hits right now. Won't blow us off the mezzanine here. And go over here. I'm one short. Oh well. Go grab another one. Aha! There's the storm. I'm not afraid afraid of a storm. Let's make another railing. Good. Oh. It's good I have magnetic boots. All right. Let's see. You need to go here. Done.
Hydration critical.
You got 4 MPa. Still working. 4 MPa. So what'll happen is hot water goes in there and then it cools off and then it tops it up because the pressure will start to drop as it cools off. So it will cycle on and off quite a bit. But that's okay. The other problem with this system is that it's leaking quite a bit of heat into the workshop because those are uninsulated liquid pipes. But I'm not that worried about it, especially now that we have a way to recycle our waste tank. A little extra heat in here is just not going to matter that much. We're going to need those when the storm ends. And, oh yeah, you still had copper in there. Good. We can happily consume ourselves some water. Oh, cool you down. Consume some water without actually rationing it for once. That's nice. What are we doing in here for oxygen and... Oh, carbon dioxide 1%. That's not too bad. Door wasn't open. Okay. Good. Uh, 2.63. Mm-hmm. Let's go in here and we're going to see how our waste tanks are doing, if they're down to temperature yet. You could just dump them out into the atmosphere, but I mean, you don't even have to make this volume pump thing. Oh, it's doing well. Still hasn't filled up enough oxygen to start filling the tank. How are we doing? 40 degrees, 36, that's pretty good. You could just dump it in, but then you're overheating a little bit. So I like to let it get down to temperature first. You could also just, open the valve in here. Like, you don't have to make this whole contraption here, but I like to empty them out to 0. I don't know why. Just being pedantic, I guess. That takes a long time. Okay, done. And you go there. Let's swap this one out, and we might as well just leave this over here to cool down as well. What temperature is it? About 200 C, yeah. Okay, that's not too bad. The greenhouse can handle it. Alright, now with these extra plants, it's actually generating a bit more oxygen. And we put a bunch more oxygen in the atmosphere, so we're up at about 4%. Alright, let's harvest some tomatoes. That means that oxygen filter is going to be on right now all the time, trying to get the oxygen level back down to 3%. There we go. Well, I think we got a lot done here. Pretty happy with that. We have a water setup going. We have a canning setup going. Yeah, I think that's the end of episode 9. If you want to join me for episode 10, make sure you subscribe. We're going to start looking at some other interesting things like getting some Constantin eventually. That may not happen exactly next one, but we're going to start on it next time. Yep. Thank you for joining me. Make sure you subscribe, and I'll see you next time.